Alright, so welcome back. So today we're going to be working on these four questions. We're going to go start with number one and go in order. Pause the video now if you want to try it and come back for the solution. Presumably you're done the solution. So for number one, this is actually pretty straightforward. So we know that pH equals negative log H plus. Now, we know that the one problem here, this is a base, and therefore we should first consider pOH, which is, so we know that pH plus pOH equals 14. So we know that, so we can get pOH pretty easily since it's a base. So we know barium hydroxide will produce hydroxide ions in water. So we know that 14 minus P8 OH equals pH. Alright, very well and dandy. So let's first write out a solution reaction to that. And we want to find the concentration of, and we recall that pOH is just negative log OH minus. So let's actually first we need to find this. So find this. And we know that BaOH2 yields Ba plus 2OH minus 2 plus. And if we draw out a little chart here, before, after, eat, well, I didn't even need that third line, so that's fine. We know that we're given 6.24 grams of that, which if we divide through by the molar mass, grams mole, and the molar mass of that is, here, let me just use Google real quick. Never mind. We're going to do it the old-fashioned way. Quit app 7. So barium 56, so 137.327. 327 plus 2, 15.994 6.24 divided by that. We know that we can get that. So this is molar mass is about 171 grams, and I get 0.0364 mole. And when we do the mole ratios, this is times 2 over 1, and we get that, if we double that, we get 0.0728 mole. And then remember that concentration is just moles over total volume, so 0.0728 mole over, and we said we had 200 liters of solution, so that would be the same as saying 0.2 liters, which yields a concentration of 0.364 molar. And now we can plug it into our, now we can plug this number, we can plug this number here, and we get that the pOH is, log answer is 0.438. You get that the answer is 0.439. And then we can plug it into here because that's our pOH, and we get 14 minus that is, which is 13.6. And that's our answer for number one. Pause the video now if you want to try number two, and come back for the solution. Alright, I assume you're back. So first thing we want to do is calculate the total H plus concentration, and the total. So we know that we again know that pH is pH equals negative log H plus. And now we need to find the total H plus concentration. So we know that, so we can split this up into really two separate sort of equations. So we know that concentration equals moles total over volume total. So what I like to do is I'd like to split this up. So H2O4 2H plus plus O4 2 minus. And I would like to consider first of them individually. H plus plus NO3 minus. I'd like to consider these individually. So that's the way I like to do things. First, consider them individually. So I want to first calculate the total number of moles. So we had 1 molar. So I gave myself nicer numbers here. So we had 100 mil 1 molar and 350 mil 1 molar. I gave myself sort of nicer numbers here. So 0.350 mole. And then since again mole ratios, doing our mole ratios, that's double, so 0.700 mole. And then we again 0.100 mole. And then again doing our mole ratios, so I'm just doing N equals C times V in my head because these are nice numbers here, so N equals C times V. And doing our mole ratios here, this is 2 to 1, so I doubled that. This is 1 to 1, so I keep it the same. 1, 0, 0. And the total moles of H plus in the new solution is 0.700 plus 0.100. Since they both contribute H plus to the solution, it's the sum of their contributions. And the total volume is 0.1 liter plus 0.35 liters. Since I know that there's 1,000 milliliters for every liter, I just again am doing things in my head because metric numbers are really nice to work with. So 0.7 plus 0.1 over 0.1 plus 0.35, which yields me a net concentration of 1.78 molar. So if I do negative log 1.78 molar, which yields me a negative pH of negative 0.249. And that's our final answer. You may be wondering why we're getting a negative pH. While log of anything beyond 0 is not mathematically possible, it is possible to get super acidic solutions. You just dump a shit ton of acid into a beaker, and this is sort of reflecting that. So while the pH scale just typically goes from 0 to 14 in your high school environment, it is possible to get negative pHs. So, and that's just reflective of, okay, this solution is super acidic. So, yeah, that's sort of an interesting thing to note here. So, while our answer may not seem to make sense, we can double check our math, and that is right. And then we also should consider the fact that we are mixing two highly concentrated, very strong acids, and therefore we get a very negative pH. Now, in practice, H2SO4, while a diprotic acid, let me explain this for the higher levels. I'm on this screen. SO4 is in equilibrium with HSO4 minus plus H plus, in equilibrium with 2H plus SO4 2 minus. In practice, it's actually this species here that is the most abundant in solution. Some of the molecules obviously fully ionized. However, um, it does technically it does fully ionize in water, but it doesn't lie here, but it technically does lie here. So that's another thing to consider, that okay, these questions aren't realistic. I just sort of made them up in 2 minutes. But there's that. So that's the answer to that one. That's the answer to that one. Had we made the assumption that this goes to here and doesn't stop here. So yep. Try the third question now. I'm going to give you a few minutes, well, mostly while I erase it to do it. Right. So, right, we're going to come back to our whiteboard here. There's an easy way to do this and a hard way to do this. The hard way to do it, let me just show you first. I'll do it the hard way first, and then we'll do it the easy way first. So we have to use the dilution formula. So now, if you're not aware of what the dilution formula is, it's just a rearranging of, we know that C equals moles over volume, and then we can therefore write that N equals C times V. So CA times VA equals CB times BB, right? So this is after and before. Since the number of moles stays constant, the volume and the concentration therefore change. So we know that we go from a total volume. Remember, our new volume is 990 plus 10, which is 1,000. So we go from 10 times, well, whatever a pH of 14 works out to be. What is that? 1 molar, I think? Hang on a moment. I meant 14. So yeah, that has a pH of 14. So pH of 14. So that has an H plus an OH concentration of, about 1 times 1 molar. So that has a concentration of 1 molar equals 1,000 times CB. And we can do 10 over 1,000 equals CB, which is about 0.01 molar. And this is, when we take the negative log of that, that's a pOH. So log 0.01 is pOH, which yields us 2 equals pOH, and 12 equals pH, knowing that pH plus pOH equals 14. Right? So that's the hard way to do it. The much easier way, and the way you really should be doing it, is so you should be going, there's a much easier way to do this. If I can delete everything. The easier way to do this is that going from 10 to 1,000 is a difference of multiplying by 100, which is the same as 10 to the 2. And since we know that pH is logarithmic, right, if we increase it by 10, so a pH from a difference of 2 to 3 is the same as increasing it the H plus concentration tenfold, or 10 times. We don't have to consider the exponent here, up here. So we can just do 14 minus 2 equals 12. Because we're diluting by a factor of 100, we reduce our pH by a factor of 2. Because again, 100 equals 10 to the 2, and if you take the log of that, the minus log of that, if we take the minus log of that, it's minus 2, and then, that's sort of, the idea here is that we use the fact that pH is logarithmic to sort of come back down. So we can, if we rewrite this 100 as 10 to the 2, we know that since pH is logarithmic, we really only change by 2. Whether it's increase or decrease by 2 comes to the fact that either we concentrating the solution, making it more concentrated, or diluting it, making it less concentrated. If we're making it, and also too, if it's base or acid. If it's acid, you add, and if it's base, you subtract. So diluting an acid increases the pH, where diluting a base decreases the pH. So although that stuff should be fairly intuitive, but the idea here is that you want to make use of the logarithms here to really make your life easier by considering powers, and then by considering powers of 10 that are nice and even, and then yeah, you make your life easier. This is a common multiple choice question on the IB exams, and I intentionally included it to show you how you would do it and why, how you would do it the easy way and the difficult way. Lastly, we have one last question for the higher levels only. So note that this HL only is for higher levels only. Standard levels, you're free to leave if you want. Click on a different video. You make a solution of 1 molar hydrogen fluoride, which I give you the Ka value is 6.6 times 10 to the negative 4. What is the pOH of the solution? Not the pH, the pOH. Now, since we're given a Ka value, we should probably first consider an ice chart. So HF H plus F minus. So did I switch over to the other screen? Okay, good. So ice. So here's our ice chart that I like to do for equilibrium problems like this. HF H plus F minus. We know that initially those are both 0, and we are told that this is 1 molar. This is minus x, this is x, this is x. Let's call the change x. So we know these have to increase by the amount x, and therefore this decreases by the amount x. If this was a 2, we would increase by 2x, and so on. We relate it with stoichiometrically, so if we call the change, if we call this change, say there was a 2 here, say we called this x, and we say decreased by x, well, this would be increasing by half x, and so on and so forth. And then the initial the equilibrium concentration is 1 minus x, x, x. We can set up our expression here. Ka equals H plus F minus over HF, which yields to x, x, and 1 minus x, equaling 6.6 times 10 to the negative 4. Which, when we plug that in, when we use our calculator to solve that, let me just use my calculator to solve that. X squared over 1 minus x and 6.6 e negative 4. Let's see, guess is a 0. Okay, 1 second. My numeric solver is fucking this up. And we get an x value of x equals 0.025. And we can take the pH of that, so negative log of what our answer was, and we get that the pH was 14. Whoops, negative log x. We get our pH was 1. We get that our pH was 1.59. So when we do our calculation, so pH equals 1.595. Okay, now I have to change that. It should be 1.60. And since it asks for pOH and not pH, we know that pH plus pOH equals 14, and therefore pOH equals 12.4. Yeah, 12.4. That's our pOH. And that's all the sample questions for today. Thank you very much for watching.